Hello students, welcome to online lecture series for software engineering KCS 601. Myself Dr. Inderjit Kaur, Associate Professor in the Department of Computer Science and Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. So, after discussing all the phases of SDLC, we are now at software maintenance phase, that is the last phase of our software development life cycle. In the previous lecture, we started with what is software maintenance and the need of software maintenance. So, after discussing the 4 types of software maintenance, we are moving towards the cost of maintenance in this lecture, and after this software cost maintenance, we will be moving on to the software re-engineering and reverse engineering. So, what is software maintenance? Starting, as we said, it is the last phase of SDLC and it tells us what are the changes to be done in the software product even after its delivery. Means it is just to know ki how this software is being evolved. Then how we define this maintenance phase? Software performs the useful work in this period. We can say that the development time, it may be continuing from 1 year to 2 years, but the software maintenance phase, it should last 10 to 15 years till the entire life of our software. Whatever software, suppose I have designed and I want it should be continued in the future. So, that means for that period of time, this maintenance phase should survive. So, we can say that development phase, in which developers they are doing their development, they are writing their code and doing the testing for any kind of software, it may last to 1 to 2 years. But when we are once the software is being deployed and it becomes operational, every company it wants it should be continuing for the near future, means this maintenance phase is near about 10 to 15 years. So, that clearly shows that it lasts longer than the development period. Then the various maintenance activity, it involves the product improvements. In the maintenance, we are talking about the improvements in our product. It makes the software product adaptable to the new changed environments, and then we talk about the error correction in this software maintenance. So, moving on to the topic software maintenance cost. Cost of the software maintenance, it consumes a big proportion of the total budget. Whatever budget has been approved by an organization during the SDLC for all the phases of my software, then this maintenance, it involves the large portion. We can say that around 70% of the software life cycle cost, it is spent in maintenance, and rest all 30% it involves the development, it involves the requirement specification and design and then testing. Most of the 70%, most of the products they carry 70% as the software maintenance cost. And if we say ki from the effort distribution, if we see these are the 4 kinds of maintenance that we do. We start with corrective, then we move on to adaptive, then perfective and then preventive. We can say that everything is most of the time the software it is delivered in its preliminary versions. So, software maintenance has to be carried out like that way only. Then the cost of the software maintenance, how it can be controlled? It can be controlled, suppose we do the we postpone the development and then it will again increase our intangible cost. How? If we postpone these maintenance key, it should be postponed, we will check it later on. That clearly means we are addressing the modification request for the software in time to increase the satisfaction. When we are spending time in maintenance in the terms of effort and cost, that means we are just increasing the customer satisfaction. Then again sometimes it may be the case ki some hidden errors they are being introduced when we are doing the changes in our existing software product. So, that also reduces the software quality. So, that clearly say ki software maintenance cost becomes high if we are spending time and effort in doing this cost maintenance. So, if we will not be spending time and effort, that means the quality of the software it will be degraded, and that is not desirable. Then for calculating the cost of software maintenance, there are 6 models they have been proposed for the entire software maintenance, and the last 2 models that we are going to discuss, they evaluates the maintenance cost. We will be starting from the quick fix model, that is the initial one and very simpler one. Then we move on to the iterative enhancements for changes. Then third one is our reuse oriented model. Then moving on to the Tort maintenance model, and Bohem model, and Baladi and Lehman model. Let us start from the quick fix model. Quick fix model, it follows an ad hoc approach for maintaining the software systems. It identifies the problem and then fixes it as the name suggests. So, the problem is being found and then we are going to fix it. Again the problem is being found and we are going to fix it, and this process goes on. So, what are the advantages of using this kind of model? That is, it works very quickly and at low cost. Then it modifies the software code with the little consideration. So, its impact on overall software structure it gets slowly changed. Then the second model is iterative enhancement model. Iterative enhancement model says ki we should consider the changes that are being made to the system in a iterative manner. So, this model it is comprising of 3 stages. The first one says ki we have the software system analysis phase. We have to analyze our existing software system. Then the second phase, it says the requested modification classification, means how the modification in the existing software they should be classified. Then the third phase, it says ki the requested modification how it should be implemented. So, in these 3 phases let us see the diagram. So, the first is we are analyzing our existing system. This is my phase 1, stage 1 of iterative enhancement model. Then we proposed some modifications, that is my stage 2. So, after analyzing and then suggesting the proposed modifications, we are moving on to the third stage, that is my redesign the current version and do the implementation as per the changes suggested in the second phase. So, what are the advantages of this model? This model it attempts to control the complexity, then it tries to maintain a very good design. These are the very good advantages of this doing iterative enhancement model. Then the next model is reuse oriented model. It comprises of 4 stages. The first one is identification of suitable old system part that should be reused further. So, here we are going to start with the old system and we will be making the new system. So, the old system is being identified first, so that it can be reused. Then the second part, in the old system we are going to identifying the parts that should be reused, that are identified in the first step, and in the second step we are going to understand them. Then third stage says ki we are going to change the old system parts as per the suggested requirements that are now. Means as per the new requirements, now my old system is getting changed. And then fourth, now there will be some new parts and there will be some existing parts. So, the fourth step says ki I have to integrate the modified parts to make a new system. See this diagram, this is my old system and this is having its requirement analysis phase, design phase, source code and then test data. Here I am doing some transformations and making the new system as per my reuse oriented model. So, these parts can be identified in any of these 4 stages. The changes can be in the terms of requirement, the changes can be at the design phase, the changes can be at the coding part, the changes can be at the test cases design. So, as per the identification of changes in my old system, we will be making the new system by doing this transformation in the corresponding phase that is being suggested. Then the next model is my Tort maintenance model. This model, it was being proposed by Tort. So, that is why the name is Tort maintenance model. This model, it consists of 8 phases, they occur in a cyclic manner. So, it starts with requesting and it ends with operation. So, we are first change the request, then once the change request has come, we will estimate it, we will schedule it to ultimate aim is to make this change request into operational. So, after scheduling, we will write the program for it. Once the coding part is done, we will be doing the testing and documenting as per these changes that we are doing, and then this is now released. So, once it is released, we will see its operation. So, after operation, there may be the 8 phases again executed for the second request. So, if there are 8 requests, n requests, so n number of times these 8 phases will be executed as per the change request. Then the next model is Bohem model. This Bohem model, it was being proposed by Bohem and it is based on the economic model principles. This model, it calculates the cost of the software from COCOMO model, cost estimation model. Then this maintenance process, it is represented as closed loop cycle in this Bohem model. Then we are going to calculate the annual change traffic ACT and annual maintenance effort AME in this model. We will be proposing some formulas, they are calculating how much change is the traffic annually, how much effort is being done annually in the maintenance phase. So, see here we are going to decide, the management will decide everything, whatever changes we want to do. So, these changes, they are being approved by the management. Once they are being approved, now we have changes in my code. That means, I am having the change implementation. So, after I have done the change in my code, I have the new version of software. So, with the new version of software, the results are evaluated by my doing by proposed changes and the results, they are being predicted. So, annual change traffic, it is defined as the fraction of software product source instructions that undergoes changes during a year. Means it is calculated the lines of code that are being added, lines of code that are being subtracted, means all the modifications in the form of addition and deletion divided by total number of lines of code at present. So, these are being calculated during a year, that gives me the ACT, that is annual change traffic. Then I calculate the second thing, that is my AME, that AME, it stands for annual maintenance effort. This annual maintenance effort is calculated as the product of ACT, means annual change traffic, and SDE, that is the software development effort. This AME, it comes in person months. So, the modified equation for calculating this AME, it becomes AME, it is the ACT cross product of ACT, SDE and EAF, means ACT cross SDE cross EAF, where EAF is my effort adjustment factor. Sometimes it may be the case कि I will be focusing more in one phase. So, rather than focusing on entire phases of SDLC, so the EAF is calculated accordingly and also been taken care into consideration. So, the modified equation for AME, it comes out to be ACT into SDE into EAF. So, we will do one numerical problem based on this. We will be calculating the total effort of the project. So, let us take the example. We are being given the ACT for a software system is 15% per year. Then the development effort is given to us 600 person months. Compute the estimate for annual maintenance effort AME, we have to calculate. If the lifetime of the project is 10 years, then what is the total effort of the project? So, from the given data, from the given question, we are being given the development effort as 600 person months. We are being given the ACT, that is 15%. So, 15% we have written. Then the total duration for which the effort needs to be calculated is given to us 10 years. So, these three things I have written from the question itself. Now, I have to calculate the AME, that is the maintenance effort is needed to be calculated. So, it is the product of ACT and SDE. So, it will be 0.15, 15% means 0.15 into 600, that comes out to be 90 person months. And now I want to calculate the effort for 10 years. So, that means now this 90 will be multiplied with 10. So, my total effort comes out to be 600 plus 900, that is 1500 person months. Then the next model is Baladi and Lehman model. This model is being proposed by Baladi and Lehman. It tells that there is an exponential increase while calculating the effort and cost. Then that means when the efforts and cost they are being increasing, that means we are following the poor software design, it should be changed. So, this alerts us that there is a scope of changing the software design. If we are increasing the effort and cost, they are coming very exponential rise they are showing. So, the person performing maintenance using this method is now no longer available. So, the equation for calculating the effort is here, M is equal to P plus K e की power C minus D, where M is my total effort expended, P is the productive effort including all the phases, means analysis, design, coding, testing and evaluation. Then K is my empirical determined constant, C and D. C is the complexity measure due to the lack of good design and documentation, and D is the degree to which the maintenance team is familiar with the software. So, these are the constants and accordingly I am calculating my value of total effort, that is M. So, let us do one numerical based on this Baladi and Lehman model. The development effort for a software project is given to us 500 person months. The empirical determined constant K is given to us 0.3. The complexity of the code is quite high and it is equal to 8. Now, calculate the total effort expended, that is M we need to calculate. First case, if the maintenance team it has a good level of understanding for the project, means the value of D is near to 1, that is 0.9, and the second case says calculate the total effort expended M when the team has poor understanding of the project, means D is nearly equal to 0, means D is equal to 0.1. So, now the P is given to us 500 person months, K is given to us 0.3 and C is given to us 8. For the first and second part, taking the values of different values of D, we need to calculate the total effort expended M. So, that comes out to be P plus K e ki power C minus D, 500 plus 0.3 e ki power 8 minus 0.9. In the first case, it gives us 863.59 person months effort, and if we put the value 8 minus 0.1, D is equal to 0.1 here. So, it comes out to be the 1309.18 person month. So, the effort goes more if we have a poor understanding with the project. Then comes the re-engineering. Re-engineering means we are re-implementing the system to make it more maintainable. This re-engineering, it includes the redocumenting, organizing, modifying and updating the system without changing its functionality and architecture. So, this re-engineering, when it is being applied to business process, it is known as business process re-engineering. The different steps for re-engineering are setting of targets, critical analysis of existing system, and then the problem identification and then solving it as per the new thinking. When re-engineering it is being applied to software development process, it is known as software re-engineering. That means IBM, as per IBM user guide, it is defined as the process of modifying the internal mechanisms of the program or the system or their respective data structures without changing their functionality. So, it is more concerned about the existing legacy systems and re-implementing them. Then there is a difference between re-engineering and new software development, that is shown using this diagram. So, this diagram shows कि there is system specification, we are moving towards the design and implementation, and here we are proposing the new system. While re-engineering says कि we have some existing system, we are understanding that and we are doing the transformation, and then we are here getting the re-engineered system. Then what are the legacy code modifications? These are the re-reading the code before doing the changes. Here the focus is more on the overall control flow, not on the coding. The comments, if they are not being handled properly, then there is a requirement for doing that. Then they create the cross references, they build the symbol table, then they localize the effect using their own variables and constant declarations. Then they use the modern design techniques. Then comes the source code translation. Source code translation means the hardware platform update, that is the company may change the hardware design, compiler for the original language they are not being available now. Then the second reason, staff skill shortages. It may be the case that there is a lack of trained maintenance staff for the original language in which the software was being written, and now they are that language is outdated. Then the third one, the organization policy change. Suppose there is a change in the policy of the organization. So, that will these are the factors, they affect the software maintenance cost. Then occurs the program restructuring. Program restructuring means we are control flow driven restructuring, we are doing efficiency function or driven restructuring, or we are adaptation driving restructuring. The first one says ki we have the imposition of clear control structure within the source code, and the second one says we are restructuring algorithm to make it more readable. Let us take the example. Here we have replaced our if then else code with the case construct. Then third says ki we are modifying our coding style to adapt to the new programming language. Then the major advantages for doing this software re-engineering, it has the lower risk and cost, better use of existing staff, and it has the incremental development. The shortcomings are the mostly architectural or data changes, or there is a change in the data management that is being done manually. So, it takes time and they are not maintainable actually. Then comes the software reverse engineering. Reverse engineering means the process of recovering the design and requirement specification of the product from code analysis, means we are moving towards to the old system we want. So, it smoothens the maintenance work by improving the system understanding, and it produces the necessary documents for the legacy system. What is the scope? For doing this reverse engineering, we require program comprehension, we want to redocument, then we want to recovery of design approach and the detailed design. Then we want to identify the reusable components, and then we want to have the high level system description understanding. So, this reverse engineering, it includes the array of tasks, that is they are being related to understand and modify the software system. For this we require the mapping between application and program domains. Here we can see we require the mapping. Then there is a mapping between concrete and abstract levels, and to extract the reusable components, that is the main aim. So, it detects the low level implementation with the high level counterparts, and it results in an incremental formation of overall program architecture. This shows the different levels of my reverse engineering. The major advantages are it recovers the lost information from the programs and it provides the abstract information. Moreover, it improves the incomplete or outdated system documentation. So, this was all about how we are calculating the maintenance cost, then a little about re-engineering and reverse engineering in software engineering is being defined. Thank you.